how to assign oxidation numbers for the elements that are present in a chemical formula. So the first thing that I will ask you to do is take a look at the chemical formula and identify whether it represents an individual element, some sort of compound, or just a table E polyatomic ion. So when I take a look at this formula, I only see Zn, so I know that this one is an element. When I go down to the next formula, I see CH4. There are two different elements present in this structure, so I understand that this is a compound. When I take a look at the next formula, Na2SO4, I notice that there are at least 3 different elemental symbols in this formula, so this is also a compound. And when I take a look at this fourth example, ClO4, but I also notice that this structure is assigned a charge. So this is not a full-blown compound. This is an example of a polyatomic ion. So I'm going to go back up to the first formula. So whenever you take a look at a chemical formula and you identify that it's an element, this is the easiest oxidation number to assign. So the oxidation number we're going to assign, it's a free element, so its oxidation state is 0. So we write the element symbol, and the oxidation state is listed upper right-hand corner. So the next one, CH4, we identified that this is a compound, and because this is a compound, the sum of the charges each one is using, the total sum needs to add up to 0. So I like to do this a little bit with reverse engineering. So we looked at oxidation numbers and figured out the subscripts to create the chemical compound formula. Now we're going to use a little reverse engineering. So in this structure, I have carbon, and it is bonded with hydrogen, but hydrogen has a subscript of 4. So the first thing that I notice is that this structure has hydrogen. And when hydrogen is bonded to some sort of nonmetal like carbon, we automatically know that each hydrogen is using a +1 charge. In this particular example, though, there are 4 hydrogens. Each one uses a +1, so the collective positive charge being supplied by those hydrogens is a +4. And when I add that to whatever carbon is going to use, the sum has to be 0. So 4 hydrogens, each using a +1. The collective positive charge is +4. I only have 1 carbon in the formula. So what does carbon supply that I can add it to +4 to get to 0? And so the carbon is using a -4. So my carbon uses a -4 charge, and each of the 4 hydrogens use a +1. Looking at my next example, this is just a little bit bigger of a compound. It has more elements. So I'm going to do some reverse engineering. So like the previous compound, when I add up all these oxidation numbers, the sum needs to equal 0. So I'm going to get myself set up. I see the element Na, there's 2 of those, plus an S, and then I see there is also O, but there are 4 of those. So working through this, as a general rule, when I see a chemical formula that has 3 or more symbols in it, I'm going to assign first to my outside elements and then figure out the one sandwiched in the middle. So the first thing that I notice is that Na, this is a group 1. So if it's a group 1, in a structure, a group 1 always uses a +1 charge. I have 2 NAs, each one uses a +1, so they are supplying a collective +2 to the structure. Next, I'm going to move down to the O. So when I take a look at this O, the formula does not end in O2, so it's not a possible peroxide. it is not, O is not bonded to fluorine, so this is just common oxygen. So I'm going to write common there. So if it's common oxygen, right away we assign it a -2 charge. But in this formula, there are 4 oxygens, each one uses a -2, so collectively they contribute a -8. So what I have to figure out then is what does the S supply charge-wise, so when I add up all their oxidation states, the total sum is 0. So, well, -8 plus +2 leaves me with a deficit of -6. S needs to supply enough oxidation state or charge to cancel out -6. So the S must be using a +6 charge. Now take a look. This next one, we classified it as an individual polyatomic ion. So in this case, for a polyatomic ion, the sum is not going to equal 0, but the sum, when we add up the oxidation numbers, is going to equal the shared charge. And in this case, that's the shared charge. And we understand that shared charge to be a -1. I'm going to use the same technique. In this polyatomic ion, there is a chlorine, and it is bonded with 4 oxygens. And when I add up their collective charges, right? So when I add these guys up, instead of equaling 0, they have to equal that shared charge of -1. Well, I notice that there is oxygen present. Since the formula ends in O4 and not O2, I know it's not a peroxide. Oxygen's not bonded to fluorine, so it is common oxygen. So each of the oxygens is using a -2. 4 oxygens, each using a -2. The total negative charge supplied is a -8. What does the chlorine supply to the polyatomic that when you add it to -8, the sum is -1? Well, that would mean mathematically that the chlorine must be supplying a +7, because +7 plus -8 leaves us with an answer of -1.